Hi. So in this video we will see the statement and proof of parallel axis theorem, and this theorem is important for the point of your examination. Now let us see or let us understand this parallel axis theorem with a example. Okay, for that I will consider a plane area. I will consider a plane area. Okay, let G be the centroid of that plane area. G be the centroid of the plane area, and xx is the axis passing through the centroid of the plane area. Okay, xx is the axis passing through the centroid of the plane area. Now I'll consider one more reference axis which is parallel to the x-axis, okay, or parallel to that centroidal axis. Let me call this axis as axis 1 1. Axis 1 1. Okay, let me assume y bar as perpendicular distance of the centroid from the reference 1 1 axis. Okay, now coming to the statement of parallel axis theorem. Okay, now I'll tell the statement of the parallel axis theorem. If Ixx is the moment of inertia about an axis passing through the centroid, then moment of inertia about any other axis which is parallel to that centroidal axis is given by I11 is equal to Ixx plus A into y bar square. I repeat the statement, or I'll write the statement here. Statement if Ixx is the moment of inertia about an axis perpendicular to axis passing through the centroid, passing through the centroid, then moment of inertia about any other axis parallel to the x-axis is given by I11 is equal to Ixx plus A into y bar square. Okay, so here x-axis is the axis which is passing through the centroid. Axis 1 1 is the axis which is parallel to the x-axis. Then the moment of inertia about axis 1 1 is given by Ixx plus A into y bar square. Okay, now let us prove this parallel axis theorem. For proving the parallel axis theorem, what I will do is I will consider an elemental strip. Okay, at a distance y from perpendicular distance y from centroidal axis. Let me take dA as area of the elemental strip. Okay, dA as area of the elemental strip. Now we will measure. Now proof. Okay, now we will measure So for the derivation purpose, I have considered an elemental strip at a distance, at a perpendicular distance y from centroidal axis or centroid. Okay. Now we will measure moment of inertia of this elemental strip about axis 1 1. Okay. Moment of inertia of this elemental strip about axis 1 1. Therefore, moment of inertia of elemental strip about axis 1 1 is equal to I11 is equal to, so we know that moment of inertia is the product of area into perpendicular distance square. Area of elemental strip is dA and perpendicular distance of elemental strip from axis 1 1 is y plus y bar. Okay, so area into distance square, y plus y bar is the distance square, whole square, area into distance square. So moment of inertia of elemental strip about axis 1 1 is equal to area of the elemental strip multiplied by square of perpendicular distance of elemental strip from axis 1 1. Perpendicular distance of elemental strip from the axis 1 1 is y plus y bar. Correct? Therefore, moment of inertia of whole area about axis 1 1 is equal to I11 is equal to summation of dA into y plus y bar whole square. We can take the integration symbol also here. Okay, instead of summation. Now this is in the form of a plus b whole square. I will expand this now. Therefore, I11 is equal to sigma dA into y square plus y bar square plus 2y into y bar, a square plus b square plus 2ab. Now we will split this equation now. I11 is equal to sigma dA into y square plus sigma dA into y bar square plus 2 into y bar, okay, sigma dA into y, okay, 2y bar I am taking outside, okay, y and sigma dA I am taking separately, okay. Now sigma dA into y square is equal to sigma dA into y square is equal to what? Sigma dA into y square is nothing but it is Ixx. Correct? It is moment of inertia about x-axis. Area into y square will give Ixx, moment of inertia about x-axis. So in this second term, sigma dA is nothing but sigma dA into y bar square is there, no? Sigma dA is nothing but it is total area into y bar square. Okay, sigma dA I have rewritten as total area capital A into y bar square. Coming to this third term, sigma dA into y. Sigma dA into y represents sum of moments of areas about the centroidal x-axis. That is what the meaning. Okay, sum of moments of the areas about the centroidal axis. Okay, its value will be 0. Okay, how it is 0? Let me explain it with an example. What I will do is I'll consider a rectangular area. Okay, rectangular area. Let me take G as centroid of that rectangular area. Okay, now I'll divide this rectangular area into two parts. Okay, let me take total area is A, so A by 2 area of this portion, and area of this another rectangle is also A by 2. Now what we'll do, we will find sigma dA for this, sigma dA value for this one means we will find moment of sum of moment of both the areas about the centroid. Okay, if I take total width of the rectangle as b, okay, this distance will be b by 2 and b by 2, and these distances centered of this splitted rectangles from the centered of the whole figure will be b by 4, correct? B by 4 and b by 4. Now we will find sigma dA into y, means sum of moments of areas about central axis we will find now. Okay, first you find moment of this first rectangular area about centroid. It is a by 2 into perpendicular distance is b by 4 into b by 4. So assume that uh, this rectangular area has got some mass. Okay, the thickness is assumed to be constant throughout the plane area. Okay, assuming thickness has got thickness is a constant, so it is area into perpendicular distance moment. Area is a by 2 is the area, perpendicular distance is b by 4, and this area will cause an anti-clockwise moment about this centroid. Okay, this left portion of the figure is trying to rotate in anti-clockwise direction about the centroid, sign is minus. Okay, similarly if I measure moment of this remaining half portion of the area about the centroid, it is same expression a by 2 into this b by 4. And coming to the sign convention, this area is tending to rotate. Okay, assume that it is a mass. Okay, it is a mass of a rectangular body, and this mass will try to rotate in clockwise direction about this point G. Therefore sign will be plus. If you find the final answer, so it will be 0 only. Okay, this is how the sum of moments of areas about the centroid is 0. Therefore we can directly take sigma dA into y as 0. Now I will rewrite this expression now. I11 is equal to sigma dA into y square, which is equal to Ixx, plus sigma dA into y bar square is a into y bar square, plus sigma dA into y 2y bar into sigma dA into y value is 0. So the remaining equation is I11 is equal to Ixx plus a into y bar square. Okay, so to this the parallel axis theorem is proved. So we have got the required equation. So same equation we have written here. So this is the proof of parallel axis theorem. Okay, so that's all for this video. Thank you.